Okay, well, we're here with Sam Jimenez. He's a space architect based in San Antonio. Some of the questions that we're trying to figure out are what colonization efforts would look like, especially those involved in agriculture. So, thanks a lot for being here.
Thank you, appreciate it. I appreciate the opportunity to talk about space exploration, and I think lunar-based design is probably one of those things that we want to talk about when we talk about colonization and settlement on the moon, for example.
Well, terrific. Hey, would you mind telling us a little bit about your experience with colonization?
Well, okay, so
design problems.
I went to the University of Houston about 20 years ago to begin learning about space exploration and how to build lunar bases and habitats in space. Went through a program called the Sasakawa Center for International Space Exploration at the University of Houston and got a degree in space architecture. So I'm a space architect. And I've been pursuing that for the last 20 years and through various channels. And probably right about now we're seeing the a surge of activity in that direction, mostly because of the commercial aspects of what's going on in the new space, they call it, where old space was traditional government programs funded, large programs, and now we're seeing private companies and smaller companies doing it on their own as private ventures, commercial ventures. And of course, right now it's all about transportation, getting to space at a lower cost, and right now they're looking at suborbital space, eventually be orbital space. Right now there are companies that are building space capsules as a service to NASA to ferry astronauts back and forth to the International Space Station.
Now, you went to Houston for your master's program, but you say that new space has a lot more opportunities that are disseminated.
Yeah, because it's private companies. It's the private sector just leading the way to space now. NASA's now, because they don't have a solid direction other than going to an asteroid and the funding issues, there are uncertainties that are there. The private sector has stepped into that vacuum to generate business models for providing a space economy with such as space tourism, mining asteroids, mining the moon, and providing systems and maybe stations, fuel stations in space for the eventual onward trek to Mars that would come as well.
Well, terrific.
Yeah.
Well, my background is actually mostly in agriculture. I did a bunch of farming, and then I actually started a company here in San Antonio to produce hydroponic crops. And my question is, do you think that transportation has been a focus of private space companies in the past? Do you think that there are opportunities for things like agriculture in space to be innovated anytime soon with some of these private companies?
Yeah, that's the natural progression of where things will go. As you rightly say, transportation has been the focus, and it's currently the focus for lowering the cost of access to space, and we're getting there. Getting to $1,000 per pound for getting off the Earth, out of the gravity well. So the focus is on propulsion right now in those systems, but we need destinations. Okay, destinations like a space station, or a destination like a lunar base, or eventually a Mars base. And destinations also mean habitation, long-term habitation. First short-term, then eventually long-term settlement as we reach out into the stars and become a multi-planet species.
Now, as transportation costs diminish, you said maybe $1,000 per pound might be in the future. Is growing food in space an important phenomenon if we can transport for cheaply enough?
So, in the beginning, we're talking short duration stays. We're talking about missions that are 2 to 3 days at a time, maybe weeks at a time. We probably bring those materials and foodstuffs with us as well. When we talk about long-term settlement where we have populations of larger than 7 astronauts or 2 astronauts at a time, then and stays are longer than 2 to 3 days at a time, then yes, very much so. And it's not quite well understood how that will work in terms of the technology requirements, in terms of the ability to make these closed systems part of a bioregenerative system, so that when you insert a new element into the biosphere, how that impacts the agricultural system and the air supply system as well. Those things need to be understood, and they're being developed right now in some aspects of the university research that's going on, but not to the degree it needs to be done as well. So I think it's a real good niche to begin to look at, and to start looking at how do we really understand the foodstuffs and the growth of that we'll need to be able to,
Well, terrific. Do you want to talk a little bit about design challenges that you've had in general, maybe even previous projects that you've worked in? Some of the challenges that a space architect has to deal with that architects in general don't.
Okay, so if we talk about architecture on the moon, for what we call surface systems architecture, we need to talk about protection of the habitants, okay, the people that will be living there. And those are extreme environments, very harsh environments, they're very, very dangerous. You need to be able to protect from micrometeorite bombardment that's constant, and radiation protection as well. Lunar dust is problematic. Still, we don't have solutions to that.
Micrometeorites, what type of dangers do they have for?
Just the constant velocities of these small, particles hitting on the functional suit maybe, or hitting on the materials that could be abrasively discharged.
They could have enough damage to
yeah, if you get a big enough one, but the constant pitting of the materials, that kind of stuff, that erodes away the value of the surface system itself.
Okay.
As well.
And
So.
with some challenges that come with not having as much gravity or different gravity around.
Yeah, so of course we have gravity on the lunar surface, which is different than gravity in space itself. Okay, so you want, in the sense of a space station design, you're dealing with no gravity or microgravity, and you have to talk about how do you get a design that accommodates the usage of the total volume. You're really unconstrained from having to work with an up and down, and you can put facilities and experiments around the whole circumference of a module, for example, as opposed to on the surface system for Mars or on the Moon. You've got a vertical reference, form of reference, and it's a different type of design. But for example, on 1/6 gravity, you want to design for a larger volume because you have more breadth of being able to jump and reach things.
So it gives you opportunities.
Yeah, you take those challenges and turn them into opportunities. In terms of trying to design for them as a constraint, you can try and use them as a way to use it as an additional resource for you.
Terrific. You mentioned solar radiation. Can you talk about that challenge and maybe some strategies that you have?
Yeah. So on the Moon, the current thinking is to bury modules under the regolith, lunar soils, regolith, and go down about 3 feet and bury these things, and that way you can get some protection from the radiation environment. But then you have other issues. The cosmic galactic radiation is still problematic because there's secondary radiation issues that occur. They can still penetrate into the module. So you have to deal with maybe mitigation strategies of length of stay on the surface as well. One of the things I like about what we've recently discovered up there are lunar caves. Caves on the Moon to me are the most natural protective barrier you can use, because they protect you from radiation, they protect you from the micrometeorites, they protect you from the lunar dust, and they also provide a temperature that's constant and benign, so you don't have to worry about designing for the extreme temperatures of lunar day-night cycles. That way you have more choice of materials to use, and don't have to design into those temperature changes that occur.
And if my experience is correct, you've done a little bit of work in analyzing the caves on the Moon and the opportunities that they might present.
Yeah, we have a project right now. We call it LEAP, Lunar Ecosystem and Architectural Prototype 2. The first one was a graduate program. So this one we're talking about a real program where we're actually using it as a framework for developing technologies to first learn how to enter these caves. They're usually at the bottom of a large skylight or pit, which is an opening to a lunar lava tube, a collapsed roof. That at the bottom of it is the entrance to the lava tube in the cave itself. But they're deep, they're big, and they're 60 meters in diameter by 150 feet deep. So they're dangerous, with loose rubble and rocks strewn around. Getting in and out is going to be a real problem. So those technologies of how to access this is the first thing you want to do. Is step wise in terms of understanding how to get to the cave and use them for habitation. Those are reconnaissance technologies. where we send the robots up first and to do the exploration and do the characterization of the site, understand how to how to measure it, so we can start eventually designing the systems that we need to have to eventually throw in there for habitation. Then comes the astronauts. Okay, the astronauts still in reconnaissance phase, come putting eyeballs on the site, understanding what's there, and really determining whether this is a location that could be used for long-term habitation and settlement. After you do that, then we start talking about the operational phase of it, and we're still talking about longer duration stays, longer than 2 or 3 days at a time. Maybe you're talking months, weeks to months at a time, and maybe those are where we would see the beginnings of agriculture coming in, where you have maybe hydroponic, a rack that's going to feed a certain amount of people for the small time frames. After you get that part of it done, then we start talking about building an infrastructure, really thinking this is a long-term stay. We'll build a complete infrastructure there, and maybe utilize the opening, the volume of that opening by putting a dome on top of it, and increasing the ability to get out of the spacesuit, get out of the modules, so you have more pressurized volume that's more larger for you to move around in, and the agricultural systems that go with that. As the growth of that community develops, now we're talking about hundreds of people at a time, are really important, because you have to deal with these highly attuned systems that are affected by one person being there minus 1 day and maybe gone the next day, and that system's got to be able to accommodate the bioregenerative flux that's occurring from time to time.
Now, agriculture would hopefully produce food, but are there other opportunities that an agricultural system, for example, that would be in the LEAP 2 program or in that
Yeah,
cave?
sure. So we see agriculture for oxygen production,
Okay.
water production, and food and fuel. Essentially, that's part of the closed loop system that we use it for as well.
Okay, and so is a lot of design challenges in space. People like to create inflatables to resolve those things. Are those things good long-term strategies? Can they withstand the micrometeorites and solar radiation problems?
Yeah, we would design for 10 to 30-year lifetime, for instance, with the structures as well, and then we can put. And there's protective material that can be used around the inflatables as well. So yes, those are very viable solutions because they offer lightweight abilities to not have to bring so much mass at one time, and also and packaging constraints that are alleviated because you can package them into the delivery system, and then it become expanded as well.
Terrific.
Yeah.
What sort of challenges do we have to overcome, or what strategies should we take here on Earth to make these types of technologies and missions more likely?
Well, part of LEAP 2 is actually the bigger component of it right now is education. We're looking at how to build a pipeline of STEM-educated engineers that are focused on space exploration. And by that, we're looking here in San Antonio. We're trying to develop these test sites, analog test sites, essentially, that allow student population, researchers, to be able to devise their experiments, devise their robotic projects, and put them into a simulated environment in a real-world application as much as you can get it. For example, there's a concept we have for a zip line that is shot across this pit opening to allow you to deploy a science package from a deployable platform to the middle of the hole, then drop it down via the zip line. So those are opportunities for students to learn about mechanics and trajectories and robotics that they could be experimenting with and testing out at an actual site, full-scale site, that simulates the rim of the pit and shooting a harpoon into a cannon cave wall or
so it would get educational opportunities as well as good research.
As well as good research out of it as well. Another thing we would look at is the astronaut cave training. How to learn the way you actually operate in the exploration phase of teamwork, working inside the cave in this dark unknown expanse. How do you actually? What are those scenarios for? How do you communicate with your robots, communicate with your comm systems, and communicate with each other as you go down, and explore these caves? So and we'll be able to teach them in a real setting that has a spacesuit basically, and they're simulated and walking through these cavernous expanses to work the operational scenarios as well.
So, new space requires a lot more private enterprise than old space did. What's the role that NASA and other JASA or some other government programs might have in new design challenges, maybe even agriculture in the future? Do you think that these are mostly private ventures, or do you think that...
It's a government-private partnership, I believe, for the most part. For the government side, they're good at NASA and JAXA, the Japanese Space Agency, for example, as you mentioned. They're good at developing the technology itself, and then using that and then pushing that technology out is what we need to do to get private space companies to help with some of the solutions, and use those technologies for their particular problems as well. So I see NASA being more technology focused and oriented, as opposed to their developing government funded big mission, go to the moon and whatnot.
Do you think implementation of the technology would be private, but development might be public?
Yeah, yes, pretty much so.
Interesting.
Yeah.
Well, okay. Well,
Yeah.
where do we go from here? Do you have any predictions about what you think
I
design
think-
in space will look like, or maybe agriculture?
Well, to agriculture, if you look to for example, Mars colony, it's a long-term prospect in terms of getting back and forth and getting supplies. You want to be able to live off the land, but you have issues where maybe maybe a disease breaks out, maybe there's food shortages, whatnot. How do you deal with the short-term emergency situations like that occur? I recently saw Craig Better from he's one of the innovators in the Human Genome Project, has an institute called Better Institute, where they're currently developing a device that actually they've been able to software code the genome into ones and zeros, and then take that in reverse, make the ones and zeros back into a DNA software as well. So they're able to transmit, via electromagnetic waves, the code, the genetic code for cells that could be sent to the lunar colony, and those cells then could be grown at the lunar colony, and you're actually doing a transportation of the thing, of the cell structure, instead of waiting for it. You start developing it right there on the side.
That is crazy.
Yeah, I think that's where we're probably going to end up going in terms of transporting medicines or whatever, but being able to do that, it's digitizing really the cell structure.
Okay.
As well.
Well, it seems like these design challenges, agricultural challenges, are all part of the equation when it comes to exploration.
Very much so. Very much so.
They probably are important in addition to solar sails and other propulsion strategies that companies like Sunjammer might provide. So, Sam, I really want to appreciate it.
Yeah,
Thanks for coming by.
Yeah, glad it. Got to do it. All right.